Just like there are different pipe joining methods and different pipe materials, with each having its own sweet spot, the same applies to bolting materials and also to gasket materials and types. In my hand I have a black steel bolt. This is the traditional material of use for bolting. A black steel bolt has no coating on it. There is no corrosion protection at all. So if you are going into a corrosive environment, for example a buried application, it would be quite normal to put mastic around the bolts and the flanges and then to apply a petrolatum tape wrap, for example Denso tape. All bolts need to be traceable, just like all flanging and other listed components for compliance with the ASME B31 series or the AS4041 piping standard need to be adhered to. And the method or the way that we can tell what the bolt strength is by looking at the head, and the head gives us the clue based on the markings. So there will always be a manufacturer's mark that will give either their brand name or the manufacturing company name or an initial to signify the manufacturer, but then there'll also either be numbers or there'll be lines. This one has lines on it, and those lines will tell us the strength of this black bolt. My next bolt is a galvanised steel bolt, hot dip galvanised, so carbon steel hot dip galvanised. Looking at the markings on the head, I've got 3 lines, and I've also got a manufacturer's mark, and I've got the numerals 8.8. So this would be a grade 8.8 bolt to the metric system. We would class this as being a high strength bolt. Another hot dip galvanised bolt here, and this one has the marking 4.6. So this is your garden variety carbon steel hot dip galvanised bolt. So the 4.6 bolt is not a high strength, the 8.8 is the higher strength for use in flange applications. Now on here are 2 washers. With regards to bolt up, it's typical to have at least 1 washer. In the water industry, if you're complying with WASA codes, you'll have 2, or you'll always have 2 washers if you want to make sure that you don't want to damage the paint coating. So if you're dealing with FBE, so fusion bonded epoxy items, then you'll typically have the 2 washers, because even though you're only rotating the nut, you want to make sure that you don't score or scratch or damage the coating in any way, which will then lead to localised corrosion. In terms of corrosion, this was a galvanised, or is a galvanised 4.6 carbon steel bolt. This has been in service for many years, and structurally, in terms of structural adequacy or structural integrity, there's nothing wrong with this. It has just corroded, and by that I mean that the sacrificial hot dip galvanised or zinc layer on the outside has actually now been used up. So it is a sacrificial or consumable coating, the zinc coating. So that needs to be bared in mind. So you do have to swap out bolts if you still want your pipe work to continue for its useful life. And my final bolt is only a very small bolt. This is a stainless steel bolt, and the markings on the head of this bolt show me A2-70. So A2 indicates that it is a 304 stainless steel, and the 70 would be an equivalent of an 8.8, so it's a higher strength. In terms of other stainless steel bolts, if I had an A4 would indicate 316 stainless steel. So the most common types of stainless steel bolts are going to be A250, A270, or A450, A470. A2 is 304 stainless steel, A4 is 316 stainless steel, the 50 is equivalent to a grade 4.6, and the 70 is equivalent to a grade 8.8 in terms of flange bolting compatibility. There are other materials that we can use for bolting, for example Hastelloy if we're dealing with some nasty chemicals, but in terms of the most common, your black, hot dip galvanised or stainless steel are your 3 most common types.